When it comes to programming, there are a lot of things to understand, but there's some issues in learning programming because if you just do just straight programming, you'll miss some of the concepts and some of the theoretical stuff that really helps you understand computer science as a whole and some of the processes and theory behind programming. If you really focus on some of that stuff, instead, you might never actually get to the programming aspect, or you might be so lost by the time you do start programming that you don't know what they're talking about. So you kind of have to balance out learning to program and learning the theory and some of the computer science concepts with the programming. So there's some things that I'm going to go over and discuss first before we jump into a bunch of really rigorous programming. We're going to build along the way. Now there are lots of languages out there. So if we do like wiki list of programming languages, there it is. Let's zoom out a little bit so you can see the letter A and B and C and D and E and let's so on. And this is an incomplete list because these are just the ones that whoever helped work on this article knew about. Now, of course, Wikipedia is a conglomeration of information, right? It's not one person probably doing that. It's probably multiple people. But there are still going to be some languages that they probably missed. There might be some private languages that are not available to the public. There may be some languages that were created kind of for fun and aren't really seriously used. There's a lot of languages. And I have seen languages that are not on here from articles and stuff, but they're not widely used. They're there for a specific purpose, a private group, a small number of people, something. But there's a lot. Another place that you can find quite a few languages, Rosetta Code, is pretty cool in my opinion. And you can see quite a few of the languages on here as well. If we go to languages here, they've got a good number. Some that don't even start with letters, like .ql or 815, 4DOS, etc. There's a good number on here, and I think they've got some special characters. Yeah, that's interesting. They've got some special categories for M, and that looks like Cambodian actually. So there's a lot, and there are some languages that are missing from this list as well that I have seen before. So there's quite a few. Now, you might be saying, well, what's the best language? And the thing is, there's not a best language. It depends on what you're doing. There might be a best language for what you're trying to do, or for your skill set, or for what your program is going to be run on, but there's not a best language, period. There are some really good languages, and there are some pretty bad languages, but to say there's an absolute best or an absolute worst, probably not true. So let's actually make some things. So by now, you should have done Hello World in Python, right? And that should have been pretty easy. We can actually look up Hello World on here. This Rosetta Code is pretty cool. It shows you what a basic program would be in all of these different languages for like that specific program. So like the Hello World program, there's a lot. These are some of the different ways that you could do Hello World in Python. So print Hello World, print Hello World. You saw both of these, right? Here's the version in Python 2. Here's the version in Python 3. There are others as well, though. So like if we want to go up to like C is a very common language. This is what it might look like in there. If we want to do C++, that's what it might look like there. If we want to look at Java, because Java is a pretty commonly taught language, this is what it would look like in Java. Let's see. COBOL is a pretty old language. This is what it would look like in COBOL. Fortran is a pretty old language. It was designed to process formulas. This is what it would look like here. So there's different ways it can look. And then of course, this is like the most basic program you can like write. All right. Now, just because you saw what it might look like in other languages doesn't mean that you understand some of the differences in languages. One of the biggest possible differences between languages is whether it is a compiled language or an interpreted language. So let's go ahead and write a couple programs really quickly. let's go ahead and do the Spotlight search. So I just did Command space to pull it up real fast. We'll go to text edit. And I already have this set up in plain text mode, right? I did that with preferences, right? So plain text, get rid of all those things. Come over, that should be fine. Yeah, like that. All right, so for Python, we could do like basically print hello world, right? Like that is one way to do it. Let's make this bigger so you can see what I'm doing. So if I save it, hello world.py, maybe I want some spaces in there. For spaces, you use underscores. You don't use actual spaces because they're a pain to deal with. So I can save it, and now I can open terminal, and say Python. Oh, wait, let's go to my desktop. CD, desktop, that's change directory, desktop. And now I can say Python, run my hello world.py file. There we go, hello world, right? Now what would it look like if it was in C? It's from like 1973 or so, but it was really important, and a lot of modern languages are based on C. Not all of them, but a lot of them. So if we were to do this, what we would write, we would need to first include the IO stream. That's input, output, stream. And then using name space standard. And then we do int main. It's a function, so functions have parentheses after them, and I know you don't necessarily know what these mean yet, but it's okay. Then we need to open a curly brace. The function is contained within the curly braces, so our hello world is going to be contained inside of that. I like to use white space, but it's not actually required. We're going to do cout, and it's going to, what it's going to push out is hello world, and close that string, and then, oops, end the line, and then semicolon. Almost everything is finished with a semicolon, so you have a semicolon there, you have a semicolon there. There's no semicolon here because we didn't finish it yet. This is all kind of part of that same thing. We are defining the main function. And then we say return 0. The reason we do return 0 is because it's expecting a number to come out of this function, and it's expecting a number because I said int. Now you might say, well, like, why did you say int if you like are gonna just return 0 and that's not the point because you're printing a hello world? Programming was originally designed to like do math, to do calculations and stuff like that. So some of the older languages are like designed like kind of at the core to work with numbers or to have numbers come out of them. So this is sort of the standard practice. Even if it's not necessary anymore, or even if a lot of languages don't do it anymore, a lot of the older ones do, or the standard practice in a lot of very traditionally styled languages is to have an int main with just like a return 0 if that's not the point of it. Okay, so like you can see a huge difference, right? Like this versus that. And that's not the only difference though. So if I save this, this is saved as hello world. I'm going to use camel case, so first word is lowercase, all additional words are capital, and it's .cpp. That's the extension. So some languages, like Python, they suggest that you use snake case. That's where separate words are separated with an underscore. More traditional languages, like C, like Java, will often recommend camel case. So you don't separate words with an actual like space or an underscore. You just show the start of a new word with a capital. So we can hit save. We should now have that on my desktop. Here it is. So here's the Python file. Here's the CPP file. That's not really important. Now the next step is how do we run it? This gets interesting. So with the Python file, we just ran it and it ran. But we can't do that with this. The command to run this, if we could run this right now, would be dot slash, I guess it would be hello world dot out, but it's not going to work. Yeah, it doesn't know. Instead, what we have to do is we have to compile it. So Python is an interpreted language. C, Java, some of the other languages are compiled languages. It varies. So we have to compile it. So what we do is we do G++. This calls the compiler, and now we need to tell it which file. Now we're still on the desktop, right? We're still on the desktop, so we don't need to do cd desktop first. We're already there. We call the compiler, and we tell it the name of the file. So hello world.cpp. And here we go. We have this. Oh, I called it .out because I knew it was going to be called .out. What if I instead called this CPP, like the actual extension of the file? Yeah, permission denied. It doesn't know what to do. Okay, so we're going to do that same thing. We're going to do /. Now this isn't hello world.out. This is a.out. So we need to be a.out. And there we go. It printed hello world. We have to do all of that and the compiling to be able to print this out. Now, if we don't like a.out, I guess the next question is, can we rename this? Like, can we do like hello world.out? And if we call it there, /hello world.out, there we go. So like that is the file name there, and it doesn't really matter what the file name is as long as it matches. But by default, when you compile it, a.out is what you're going to get. Now the other thing about interpreted versus compiled languages is sort of how errors work. So what if instead of this, we made variables? So let's say that we have print message, but first we have to define the message. So the message is going to be hello world. And here, let's define a variable. So the way that we define a variable in C is a little different. It's char. So this is the type. It's characters, message, and then some square brackets equals, and then the message. So a char is typically a single character. We'll go over these data types more later on, but a char is typically a single character, but here we are like making a string of individual characters. So this is a string of hello world. It's stored in a char type. So now if we want to print this, we can say message. Oh, but okay, hang on. Okay, I'm going to delete that, and I'll save it. So now if I run this Python file, let's see, where was it? Python, okay. Okay, there's an error. End of line while scanning string literal. So this is the string. While scanning this string, it had an error. I didn't close the string. I intentionally left off the quote there to close the string. So when it got down here, it was like, hey, I didn't finish the previous line. I don't know what I'm doing. Please help. So if I save it and I try again, there we go, it works. Here, let's save this. Let's go ahead and clear that because it was getting a little long. So if I try to compile that, we get an error, right? I didn't even get to run it yet. Oh wait, I have this hello. Well, yeah, it's fine. Like I have this hello world.out here, but remember by default it's going to be a.out. So we don't have an a.out because there was an error while compiling. So I have to go back and I have to fix it and save it, and then I can compile it. Here is my a.out, and now I can run this. Where's my run code? There it is. .a/.out. There we go, hello world. So it made a variable called message, which is a string of characters called hello world. It printed that message out, and then it ended the line, and then it ended the program. So that's a compiled language versus a interpreted language. Now, this is quite a bit longer than that. That isn't always the case. Not all compiled languages are longer than interpreted languages. An interpreted language could be longer. That is just the situation in this case. Now, this was the hello world for C++. There's also C, right? So I talked about this here. If we go back to Rosetta Code,